Welcome back. This video is a continuation of the previous video on one of the applications of partial differential equations on heat conduction in a rod. Our aim was to find out the temperature at any point and at any time using the finite difference method. We had said that there are two methods. One is the explicit method and the other is the implicit method. In the last video, we discussed the theoretical aspect of this method, and we also concluded by stating the working rule to solve such BVPs. In this video, we shall be working out some problems based on the working rule. So let's begin with the first problem. The first problem reads the following. Solve the equation 16ut equal to uxx, where x varies from 0 to 4 and for all positive t. Two conditions are given. U of 0t is 0, u of 4t equal to 8, and u of x0 is also given to be some function of x. We need to take delta x is given as x half and delta t to be 1, and this line is important up to 5 time steps. So what is it that the data in this tell us? First of all, they're looking at the equation which is of the required form AUT equal to UXX, which is our standard 1D heat equation. So we are able to get the A value from the equation. Note the range of x range is given to be 0 to 4. Now these two conditions, how do we read this? The temperature, which is U, is 0 at x is equal to 0, meaning it's a boundary condition. The temperature, that is U, is equal to 8 at x is equal to 4, that is another boundary condition. So these two are given to be boundary conditions. Then here you're given temperature to be some function of x at t equal to 0. T equal to 0 meaning initial, so that means you are given this initial condition. So as required, we are given two boundary and one initial conditions. Now delta x, as I said in the example, it refers to the step size h. Delta t refers to the step size in the t direction, and this is important. Now we definitely know the range of x, isn't it? X is from 0 to 4. Now we need to know, okay, we are starting at t equal to 0, but where are we going to stop? At what, till what time do we require? Now this is what is going to tell us what is the upper limit of t. And that's very important. So let's start off. I'll be doing the problem. We shall discuss that point. So step 1, as we discussed in the previous video, we write the given BVP, mention the equation, write the range of x. Now the range of t, this 5, we will, for now you omit it. I have written it as 5. Why have I written? You will know a little later. Then boundary conditions, let us write the two boundary conditions. Again, I have mentioned it, the t range till 5. Now why did I mention it till 5? Let's see later. Then we shall write the initial condition as we discussed. X range is fixed to be 0 to 4. Now I told in previous video the working rule, we have to identify the value of A, H and K. So A is the value of UT. You see the value of UT here is 16 and the coefficient of UXX is 1. So perfect. The value of A is 16, H value is half, K value is 1. So all the three are known to us. So we simply have to substitute it in that parameter lambda, which is given by K by AH square. I substitute the values of A, H and K in it. Get the value of lambda to be 1 by 4. I see that the value of lambda is less than half, and so I use the explicit scheme here. That's the conclusion of step 1. But before we go to step 2, we still have to find the range. I told you, isn't it? How did we get this 5? We have to note. So we have to discuss till the range of t. Now since k is the step size in the t direction, let's draw a vertical line mentioning that it is in the direction of t. Let us start it at t equal to 0. Let's start at t equal to 0. That's our first point. Now what is the step size in the t direction? It is k. K is equal to 1 is the step size in the t direction. And how many time steps have we to go? As given in the problem, we have to take up 5 time steps. That means I have to take 5 jumps along the t direction. So let's make the first jump. It is this. this. So what's the k value there? K equal to 1. So you are making a jump of 1 unit, and where are you going to arrive at? T equal to 1. So first jump is already taken. First time step is already done. How many such time steps we should calculate? 5 time steps as given in the problem. So let's take the second time step, another k equal to 1. Where did you reach? T equal to 2. Take the third time step, k equal to 1 again. Where did you reach? T equal to 3. Take the fourth time step, again where did you reach? K equal to 1. T equal to 4. Take another time step, k equal to 1. Where did you reach? T equal to 5. So have you finished with all the 5 time steps? So what will be the range of t therefore? So this is your t equal to 5 seconds. In fact, it is 5 seconds. 0, 1, 2, 3, 4. We are talking in terms of seconds. So at 5 till t equal to 5 seconds, we need to know what is the value of u at given x and given time. So our range of t is varied from 0 to 5. Now you don't have, now that's the reason why we have put 5 here. So I'll erase this part and keep it as 5 throughout. Now that point would have been blank initially. After computing it like this, we would get to know that the range of t is 5, 0 to 5. So that completes step 1. We have got the value of lambda. We have got the range of x and t. Now let's proceed with step 2. So let's move to step 2. We have found the value of lambda to be 1 by 4, which is less than half. So the explicit formula is used. We decided that earlier. Let's write the explicit formula. Let's also draw the figure, the diagram there based on the 4 values. So what do we see here? This is the value here. And now before you write the coefficients is what we normally write. Put a question mark and for the left hand side. Now the first coefficient for u minus 1 comma j is lambda. But what's the value of lambda? The value of lambda is 1 by 4. So let us write that as lambda equal to 1 by 4 here. Then what's the next coefficient for ij? It is 1 minus 2 lambda. So I substitute 1 by 4 as in place of lambda and get the answer as 1 by 2. Then for u I plus 1 comma j, it is lambda. So lambda here again is equal to 1 by 4. So that completes my completion of the diagram. So what is the formula now? The unknown will be, this is the unknown will be equal to 1 by 4 times the previous value, then plus 1 by 2 into the ij value plus 1 by 4 into the right side value. I add up all the three and that will be the value of the question mark. So it's something like this. So suppose I have a value like this here and this is my question mark and I have here the value given to me in this star, this box. I have drawn circles, so let me draw circles here too. And the coefficients is 1 by 4. Say the value here within, I will not put a squares, and I put it say as 2. And here say I rub this star and I put it as 1. The coefficient is 1 by 2. I rub this star again here and I put it as say 0 and the coefficient is 1 by 4. So what will be the value of this question mark? The question mark now will be equal to, I can draw the lines as we did here. Now this is the scheme. So how do I find the question mark when I know the values? It is 1 by 4 into the value within the circle is 2 plus 1 by 2 into 1 plus 1 by 4 into 0. This is how we compute the value of the unknown. I repeat, it is 1 by 4 multiplied by 2 plus 1 by 2 multiplied by 1 plus 1 by 4 into 0. That will give me the value of the question mark. This is how the scheme is going to be applied in the later stage, especially in step 5. So let's see that in the next slide. Our step 3 is to find out the values of x, t, I and j as we also discussed during the working rule. So let me write the range of x and t. So the range of x is from 0 to 4 here in steps of half. We have already discussed about it. Then we wrote x, which is written in terms of IH. We have split the interval 0 to 4 in steps of half to get all these values. Then we have divided each value. All these values are divided by h, meaning divided by half, and I get the I values. Similarly, I take t range and the step size in the t direction. T, which is nothing but jk in the finite difference form. I split the interval 0, 5 in steps of 1 to get these values. Then I divide by k. K is nothing but 1. So when I divide each value by 1, the values remain the same. I get the values of I and j finally in step 3. I will require the values of x equal to IH and I, these two values, even for my next step, that is step 4. So keep that in mind. It's a very important step that we are writing here because we use this data not only in step 4 but also in step 5. Let us now move into step 4 to write down the boundary and initial conditions in finite difference form. We had no discussion about it during the work when we discussed the working rule. We shall discuss it now. Before I start with the boundary conditions, let us recall step 3, the values of x and I that we derived, and let us write it down separately and keep. This was the first row depicted the values of I of x, which is written as IH in the finite difference form, and then by dividing all the values of x by h was equal to half, so we divided it by half and got the values of I. What this means is if IH is equal to 0, then I is equal to 0. If IH is equal to half, then I is equal to 1. This is how we keep doing. If IH is equal to 1, then I is equal to 2. This is what it means. Now let us use this concept in identifying how to write the boundary and initial conditions in finite difference form. Let's begin with the boundary conditions. The first boundary condition reads u of 0 comma t is 0. As you all know, this can be read as the temperature takes the value 0 when x value is 0 for all time t. Let us put it in the argument form. The second step would be rewriting. If you recall, we had written earlier in my previous video, when you want to convert the argument into the finite difference form, you have to replace x by IH and y by jk, and thereby write it in the suffix form as u, I, comma, j. So the coefficient of h will be written as a suffix. The coefficient of k will be written as a suffix. So this was our initial definition when we studied last video. So we are going to apply this here. When we want to convert an argument into a finite difference form, the first step that we do is replace x by IH and y by jk. There is no x here. Instead, x takes a value here. So let's retain it as it is and let us rewrite t as jk. The right side is a constant, so the constant continues itself. Now we have to replace, as I said, the coefficient of h, which is I, should be written here. That means the value of I should be written as the first suffix. What is the value of I? What is this position actually? This position is for IH. So IH takes the value 0. What is the value of I when IH is 0? Can you tell me looking at this green block? IH is 0. What does that mean? What is the value of I? So when IH is equal to 0, that is the first round which I put here, then what's the value of I? I takes the value 0. So in the suffix form, when we write this result, this becomes u0, comma, jk is now the suffix is j and the right hand side continues to be 0. Now this 0 that you are writing here is because when IH is equal to 0, that means I is equal to 0 from this table that we have drawn in step 3. I hope you understood. First step, what did I do? I replaced t by jk. There was no x to replace and therefore we just mentioned it as t as gk. jk, and then that jk became j in the suffix. But look at the first argument. The first argument took the value 0. 0 is for the argument ih. This is ih. So ih took the value 0. When ih takes the value 0 from step 3, look at this green box. When ih is equal to 0, then I get corresponding I value to be 0, and therefore u0 comma j is 0. Let us now similarly take the second boundary condition. What is the second boundary condition? U of 4 comma t is equal to 8. So now, what does this mean? First, let us write down in terms of I and j. So this becomes u of 4. 4 remains 4. T becomes jk. 8 remains 8, isn't it? Now look at the next step. Now for jk, what do you think? Can you guess it? In the finite difference form, u. First component you leave, put a comma. Second component is jk. So you are carrying j as it is equal to, the right hand side is a constant, it remains 8. Now look at the first component. You have to write a value of I. Now what is that value of I? What is the value that we have in the first argument? It is 4. And what should it be actually? IH. If IH is equal to 4, what is the value of I? You get that first from this green box. IH equal to 4. So look at the first one. IH is equal to 4. So what is the value of I correspondingly? It takes the last value. And what is the last value? It is 8. When IH is equal to 4, the value of I is equal to 8. And therefore, what do you write as a suffix in place of I? It becomes 8. And thus in the finite difference form, this boundary condition becomes U8 comma j is equal to 8. Since the reason is, yeah, IH is equal to 4 implies I is equal to 8. So that is the description that is given here, or we have explained just now. So I repeat once again, we first write it in the finite difference form by introducing IH and JK. Then when you first component should be IH, but that's taking the value 4. So when IH takes the value 4, that is this last one, last value, then I value takes the last value, which is 8, and that I value has to be written as a first suffix. The second argument for JK, it becomes J, that 8 continues to be 8. And these are called the boundary conditions in finite difference form. Let us now look at the initial condition, but before doing that, let us write down what was the values of t and j from step 3. So this green box is giving you the new values. So what is the values of t, which is jk? It's the same because k value is 1. So when dividing by 1, you got back the same. So what does this mean? When jk equal to 0, j is 0. When jk is equal to 1, then j is 1. Similarly for the others. Let us now apply the similar concept for the initial condition. So what's the initial condition we wrote? U of x comma 0 equal to x by 2 into 8 minus 6. Now let us replace x by IH. There is no t here because t value is 0. I hope you understand that. So wherever you have an x, you replace it by IH. So see what step are you getting? X value is changed to be IH here. X value is changed to be IH here. X value is changed to be IH here. So wherever there is an x, you replace it by IH. Now you rewrite the left hand side in the finite difference form. So what will that be? U of IH comma 0. Now tell me, how will you write it? U. Now IH meaning the suffix should be I. Now this is actually for JK. Now write the value of J. Write the value of J when JK equal to 0. That's the meaning. What happens to the value of J when JK is 0? So look at that. When JK equal to 0, what's the value of J? J is also 0. So what will be our second component that we write here? It will be I comma 0. So what will be the left hand side here? Ui comma 0. As I said, IH is becoming I. The second component, why is it becoming 0? Because jk equal to 0 implies j equal to 0, and then you are getting the right side. So the left hand side rewriting in the finite difference form is possible because jk equal to 0 implies j equal to 0. Now substitute for the value of h. The h value that you got was 1 by 2. So I substitute h is 1 by 2 and rewrite ui comma 0 in this manner. So these expressions, these ticked expressions which I am writing here are the boundary and initial conditions in finite difference form. Let us now use all these in step 5 and complete the table. So let us start with step 5, which is the construction of the table. The table is here. So let's start off by writing x is equal to IH first, and then t is equal to JK, and then we have I and J here. So let us fill up these rows by from step 3. So x values were 0, 1 by 2, 1, 3 by 2, then 2, then 5 by 2, then 3, then 7 by 2, and then 4. And then corresponding I values were 0, 1, 2, 3, 4, 5, 6, 7, and 8. You can see it from step 3. Similarly, the values of t were 0 to 5. And because k was 1, even j values were 0 to 5. So all these values are clearly from step 3. We are not doing anything new here. So I have just copied the values from step 3 and written down in 2 rows and 2 columns. The reason why I am drawing these 2 lines is because these boxes which are empty now have to be filled. And those boxes will represent the corresponding result, which is the temperature U at a point X and a time T. Now how do we fill up them? As I told you in the working rule, the first step is to fill the first column or the first boundary condition which will fill the first column. So what is the first boundary condition? U0j is 0, meaning for I equal to 0, all values of j. I equal to 0 means here for all values of j, meaning for the first column, all the values are 0. So you are filling up the first column by zeros. So first boundary condition fills the first column. The second boundary condition, look at this. It is u8 comma j, which is 8. That means for I equal to 8, for all values of j, the value is 8. So it is, we have filled up the last column with the number 8 for all the cells. So we have filled up 2 boundary conditions. So this was our first boundary condition and this was our second boundary condition. Now what do we have to do? Fill up the initial condition. As I told you, the initial condition fills up the first row. So these points, that is when I equal to 1, 2, 3, 4, 5, 6, 7, we have to fill the initial condition has to be substituted there. What is the initial condition? It is this. Why did I say first row? Look at this. When j equal to 0, j equal to 0 is this value for all values of I, meaning the complete first row for all values of I, you have to use this formula. Meaning, now let us look at the first one. The first one says I equal to 1. When I equal to 1, what does the formula say? 1 by 4 into 8 minus 1 by 4. So wherever you have I, you substitute that I, use your calculator, write the answer correct to 4 decimal places. So 1 point you get 8750. Once you say 2, so instead of 1 you write it as 2 wherever there is I and simplify, it becomes 3.5000. I am taking up to 4 decimals. So then 3 by 4 into 8 minus 3 by 2, and that gives it 4.8750. I am using a calculator to get the answer. So here it's 4. So 4 by 4 into 8 minus 4 by 2. So it is simply 6. So it is 6.0000. Then it is 5. So when I similarly substitute 5, I get 6.8750 and this becomes 7.5000 and finally here 7.5, then finally I get 7.8750 when I put I equal to 7. So I have filled up the first row with the initial condition. So now you see we have filled up all these values. Now comes the remaining part. What is the remaining part? These blanks which have to be filled in, you have to use the scheme, the formula. Now if you recall in our step 2 that we drew the scheme was like this. The unknown was here. that was in the j plus 1th row, we got a triangular shape. If you recall, please go back and see. I'm giving you only the gist here. So this is a triangular shape. Now you had three circles in the jth row. This was the jth row and this one was a j plus 1th row. J plus 1th row, you had only one element, and here you had 1 by 4 as the coefficient, 1 by 2 as the coefficient, 1 by 4 as the coefficient. So let me erase this part which you may be confusing. So now look at this. So this is your unknown. You put a question mark there. So the unknown is equal to 1 by 4 times. So the unknown is in the previous row. For all these blanks, I should start from this row. Start from this point where I'm putting a dot now. I should start from this point. So this will match with your question mark here. This will match with the question mark. So what is the previous row values that I need? I need a value in the previous row right beneath the unknown. That means what? It is 1.8750. Then I want a value in the previous row to the left of the center value. That is 0. Then I want a value which is to the right of the center value in the previous row. That means 3.5. So see, how do you judge them? The unknown is here. The unknown is here. The unknown depends on the previous row center value. The unknown depends on the previous row left value, the previous row right value. So here it will be, so this dot, which I say if I put it as dot, that's equal to, it is 1 by 4 into, see that? I start from the left. So it's 1 by 4 into this value plus 1 by 2 into this value plus 1 by 4 into this value. So now what will it be here? What are the values? It's 1 by 4 into 0 because that's your left value. Then 1 by 2 into the center value. What is the center value? 1.8750. And then what is the third value? It is 1 by 4 into 3.5000. So when you simplify this, you get an answer which is 1.8125. So how did you get it? Using the scheme. What is the scheme? Wherever you have an unknown, try to fix that first. Then beneath that, below that row, identify the three values. One is the center value in the before row, to the left value in the before row, to the right value of the before row. So you have got the value. Now look at this one now. If you want this value, now see, now what is your center value? Which are the values you will consider? The center just beneath it, just below it, what is it? The center value 3.5. So it is 3.5. What is to the left? 1.8750. What is to the right of the center value? 4.8750. So how will you get this double star value? Will you tell me how will you get that? Can you guess it? So it will be double dot is equal to, let me write it here. Double dot is equal to, yes, tell me. This will be 1 by 4 into the previous row left value. What is the left value previous row? 1.8750. Then it will be plus 1 by 2 into, what is the center value? 3.5 plus 1 by 4 into, what is the right value? 4.8750. So what will be the answer if you see in your calculator? It becomes 3.4375. This is how you completely fill up the table. Now if you look at this value, now you, for example, you take here, this is the value you want. Now this is the value you want. Now what will that be? Which are the values that you will consider now? So look at the center value in the previous row, the previous value in the previous row, the left value, the right value. So look at the ones that you want. The center value is 6.8750, the left value is 6, the right value is 7.5, and the coefficients are 1 by 4, 1 by 2, 1 by 4. So what will that dot mean there? It is 1 by 4 into 6 plus 1 by 2 into 6.8750 plus 1 by 4 into 7.5. So what will be the answer pertaining to this one? It will be 6.8125. 6.8125. Just check whether it is right. And this is how you will complete. Once this complete row is done, All these values are done. Then you again start from here. So for this, what will be the previous row center value? This one. Then previous row left value is this one. Previous row right value is this one. So it's 1 by 4 into 0 plus 1 by 2 into this value plus 1 by 4 into this value will give you the above value, which will be 1.7656. Like this, you go on completing the entire table. And that will give you, suppose I want, what is the temperature, what is U at x is equal to 5 by 2 and time t is equal to after 1 second. Can you tell me the answer? What is U at x is equal to 5 by 2 and after 1 second? So you see that x equal to 5 by 2 is here and t is equal to 1 second is here. Now what is the value of the U corresponding intersecting point is this. So you will say that the temperature is 6.8125 degrees Celsius. So it is something around 6.9 or it could be rounded off to 7 degrees Celsius. So this is how you judge the answer and this is how you calculate. I repeat, you complete the boundary conditions first, initial condition next, and the remaining complete table will be done based on this scheme. In my next slide, I have given you the entire answer. Please complete it in a similar manner and cross-check if your answer coincides with the main answer given in the next sheet. All the discussions that we had in the previous slide has now yielded these results. You could cross-check by simplifying, and this would be the final answer for the problem. Let's do one more problem in a similar manner. Let's take up the next problem, which reads, solve the equation with the conditions. You're given two conditions with the initial condition taking h equal to 1 up to 3 seconds. Let's analyze the problem. So you're given uxx is equal to ut. Okay, and then you're given u of 0t is 0. This is a boundary condition because it's specified at x equal to 0. U of phi t is 0. Again, it's a boundary condition, which means x varies from 0 to 5. And an initial condition is specified. Value of h is given. Kindly note the value of k is not given to us. And we have to compute the value of u up to t equal to 3 seconds. So let's now analyze and go step by step. So let's start by rewriting the given BVP. We have the given equation that uxx equal to ut and x varies from 0 to 5. T varies from 0 to 3 because we are given up to maximum of 3 seconds. That's the difference between the previous and this problem. There we were given the number of time steps and we had to identify up to how many seconds we had to calculate. That was 5 seconds there. Here we have to calculate up to 3 seconds. So the maximum limit is given to us, but we do not know what is the jump along the t direction. That is the increment along the t direction, which is k. So we have to evaluate it. Let us see how. Then the two boundary conditions are given to us. And then an initial condition is also mentioned. So the remaining is all the same. Now we notice here that the equation is ut equal to uxx. So uxx coefficient is 1 and thereby ut coefficient is also 1. So I'm sure you will agree with me that the value of a is 1 here. H value is 1, which is given to us. K value is not mentioned. So as we discussed in the working rule, if k is not known, if one of them, either h or k, in this problem it is k, then we have to choose lambda value to be equal to half. That means we are forcing the Bender-Smith scheme to be applied. And let us substitute lambda, h and a, all the values in the formula. Lambda is equal to k by ah square. Thereby get the value of k as k equal to 1 by 2. So we are able to identify k equal to half, and the main important point is wherever we do not have any increment mentioned, then we are choosing lambda to be half. Now coming to the range of t. How did we choose the range of t is 0 to 3? because it's the upper limit is 3 and we have k equal to half. So how will our the steps look like? Let's redraw as we did it in the earlier case. It is not needed because the upper limit is already given to us here. Upper limit was not mentioned earlier, so we had to draw the diagram, but here also let us see how it moves on. So we have drawn it, taken started with t equal to 0, took the first jump. The jump here is now, as we defined here, k equal to half. So k is equal to 0.5. So we reach t equal to 0.5. Again we take a jump of 0.5. Then reach t equal to 1. Take a jump of 0.5. Reach t equal to 1.5. Take a jump of 0.5 and reach t equal to 2. And then take a jump of 0.5 again and reach 2.5, and finally another jump to get 3. So we have reached that, and so 1 by 2, by taking k equal to 1 by 2, we arrived at it. It was not necessary, all this was not necessary, but because the upper limit was already given to you, the maximum time to which we have to calculate u is already mentioned, unlike in the previous issue. But this problem, this is only for clarity that we have drawn this figure. Let's move on to step 2. As we have chosen lambda to be half, we are using the BS formula, and let us write the formula first and then let us draw it. As we explained earlier, we take the jth row first, mention 2 points, corner points, left and the right points, and then j plus 1th row. We take up only 1 point, that is in the center row, center value, which is I comma j plus 1, and then the coefficients, which you have question mark on the left side, half on for the two elements in the jth row, and connect all the circles by lines and then seal it up. So this is the figure that we would be using in our final step 5. Let's take up step 3 now, the values of x, t, I and j as we did in the previous problem. Here the value limits of x is from 0 to 5, h is given to be 1, and therefore x is equal to IH as we did in the previous case is equal to, split the 0 to 5 in steps of 1, we are going to get back the same, and then we divide all the numbers by h. What is h? It's equal to 1, so the I values also remain 0 to 5. Similarly, take the values of t. T is from 0 to 3, k equal to half. So t, which is equal to jk according to the finite difference form, we split 0 to 3 in steps of half. So it becomes 0, half, 1, 3 by 2, 2, 5 by 2 and 6 by 2, which is 3. Then we divide by k. What is k? K is half. We divide by k so that the values of j will be from 0 to 6. So this is exactly as how we did the previous problem. So kindly follow it up in a similar manner. Let us now move to step 4, which is the boundary and initial conditions in the finite difference form. From step 3, we have certain values. So let us start by writing those values, x values and the I values. This is going to help us. We'll start with the first boundary condition. As we stated earlier, it's in the argument form. Now replace t by jk, keeping IH is equal to 0. When IH is equal to 0, what is the value of I? I is also 0. So in the suffix it becomes U0J is equal to 0. So JK is giving you 0. This 0 will continue to be 0. But this 0, how will it become 0? Since IH is equal to 0, I is equal to 0. That's the explanation for the I component to become 0. Let's look at the next boundary condition. You have u of phi comma t is 0, which can be simplified as u of phi comma jk is 0. Now, when you want to write it as a suffix, IH is equal to 5. When IH is equal to 5, what is the value of I? I is also 5. So the suffix will become u 5 comma j equal to 0. So jk is become j, 0 is becoming 0. But how will this 5 continue to be 5? Because IH is equal to 5. That implies I is equal to 5 from this figure, from these data. Now similarly, let us take up the initial condition and then take up step 3 data, that is kt is equal to jk, the values of j. Now let's write the initial condition and now substitute x as IH everywhere. So wherever you have an x, you replace it by IH. So x square becomes I square H square. Now look at the left hand side. Here you have u, I, suffix is I, and what is this value? Jk. When jk equal to 0, what's the value of j? It is 0, and therefore the left hand side will be suffix u, I comma 0 is equal to the right hand side. But what is the value of h given to us? It is 1. So let us substitute h value to be 1, and then we get this result. So now we have got all the initial and boundary conditions in finite difference form. Let us proceed with step 5. Let us start by constructing the table. Let's draw the table first. Then write x is equal to IH here, t is equal to jk, and then write I and j along the row and the column, and fix the values from step 3 directly in the table. So this is also 0, 1, 2, 3, 4, 5. So we have the same. Here it is 0, 1 by 2, 2 by 2, 3 by 2, 4 by 2, 5 by 2, 6 by 2, which is 3, and thereby it will be 0 when you divide by 1 by 2. It is 3, 4, 5, and 6. So I'll darken these lines because, as I said in the previous problem, the values that you're going to write in the center boxes are only the main answers. These row and column, we have just copied it from step 3. Now coming to the first column, as I said, we are going to fix the boundary condition. The first column is filled up with the boundary condition 1. So you see I equal to 0 for all values of j is 0, meaning all the cells in the first column will become zeros. So that's easy. Then look at the next boundary condition. We have u5j is equal to 0, meaning when I is equal to 5 for all values of j, so these are also, all of them are zeros. Then we have the initial condition to be filling up the first row. So what is the initial condition given to us? I square into 25 minus I square. Here I value is 1. So what will this point be? Just the above point. It is 1 into 25 minus 1. So it will be 24. Similarly, it will be 4 into 25 minus 4. So that will be 84. Then it is 3 square, that is 9 into 25 minus 9. It is 144. Then it is 16 into 25 minus 16, which is again 144. So thereby the initial condition, two boundary conditions. This is boundary condition 1, this is boundary condition 2 that we have already used. Now we have to fill up the next set of data. And as I said, we are going to use the scheme. Now what is the scheme that we wrote in step 2? We had 2 points in the jth row, and both the coefficients here were half because we are dealing with the Bender-Smith scheme, and the unknown was in the above row, the next row, and then we drew a triangle. So what does this mean? The unknown value does not make use of the center value in the previous row. It makes use of the one that lies to the left and to the right of the center value in the previous row. Or can I say that the question mark is nothing but the average of, isn't it? The 1 by 2 is into this value, sum of the values. So it is the average of the previous row diagonal elements. Diagonal elements meaning what? What are the diagonal elements? If I say so, if I want, this is my unknown. Now I have to apply the scheme. Now look at the diagonal elements up to this point. What point is it? Which is the diagonal? 0 is one diagonal element, and then the other diagonal is 84. I don't need this value at all in the case of Bender-Smith. This is not needed. So I will have 0 plus 84 divided by 2. When I say average, what am I doing? I am taking the two diagonal elements, then I am adding up, dividing by 2. So what will be this value? It will be 0 plus 84 divided by 2. So what is it giving you? It gives you the value 42. Now look at this value. Now this value will be Look at the diagonal elements. One is 84, the other value is 144. So it is 84 plus 144. That's the value. 84 plus 144 divided by 2. That's what you mean by the average. So it's simpler than the explicit formula because it's just taking the previous row diagonal elements and taking the average. So it's 84 plus 144 by 2, and that will make it 114. Let's fill up the second value also, this one. So what is the diagonal element here? The diagonal element is 24 plus 144. So 24 plus 144 divided by 2 will give you what there? It will give you 84. Am I right? It will give you the same value. Next, what is the last value here? It's 144 plus what is the next diagonal element? 0. 144 plus 0 divided by 2, it will make it 72. So similarly, you proceed further. Go ahead with this value. This diagonal element, if you see, it is 0, and this one is 84. So 0 plus 84 by 2, so it becomes 42. Look at this value. What is the diagonal element? 42. Look at the diagonal element 144. 42 plus 114. 42 plus 114 divided by 2, and that will make it 78, and so on. So like this, you can complete the entire table. So when you say Bender-Smith, you will not find an easier scheme to do. Bender-Smith is the scheme is just the unknown is equal to the question mark, as I said, is equal to the average of the previous row diagonal elements. What do I mean by diagonal? Just take the one which is to the left of that point in the previous row, to the right of that point in the previous row. Take its average, meaning adding it and dividing by 2. Thereby you will complete the table, and that would be the result. The complete answer is shown in the next slide. Kindly work it out and check the values. So the values as per our discussion are these. Kindly work it out and check your results. And this completes problem number 2. So I hope the two problems which I have done here based on the explicit method and the Bender-Smith scheme, I hope they are clear. Please work out some more problems which I have given in the next slide for practice. These are some of the problems that you could work out, and you can send your results so that we can confirm your answers. So in the next slide, I would be talking about the implicit method, which is, and the particular case called the Crank-Nicholson method. So that's also very interesting to do, and it has no restrictions like you saw in the explicit method. Here you had a restriction on lambda, but there is no such restriction there. So it is a wider applied problem and very applicable. So we shall meet again in the next video. Thank you and good wishes.